Hello, welcome to today's lesson on water and changes of state. We'll be doing a quick revision before we start on questions related to topical worksheet 2. So first, we are going to recap certain concepts of water and changes of state. Next, we are going to look at how to use stop, think, go for your MCQ, which is multiple choice questions. Thirdly, you should have already tried the questions, or you can try them as we go along. Lastly, please check your answer against the ones provided. Let's begin. First, how are we going to use stop, think, go? You are going to have to stop to read the question and then highlight or underline certain keywords. Next, think of the topic or concept tested. And when you go, annotate and write short notes. Lastly, eliminate to find the correct answers. Now let's recap on what we have learned on the water cycle. The water from the rivers, lakes and seas gain heat from the sun and evaporates to form water vapor. The water vapor will then rise and loses heat to the cooler surrounding air. As it has lost heat to the cooler surrounding air, it condenses to form tiny water droplets, which gather to form clouds. When there are too many water droplets, they will then fall to the ground as rain. The cycle repeats itself again. Now we are going to move on to try certain multiple choice questions. Let's look at the first multiple choice question. Which one of the following processes is correctly matched to the change of state that takes place in water? So let's practice stop, think and go. Let's highlight the words in yellow. Keywords such as processes, correctly matched to the change of state. Okay, let's look at the options next. First, we have melting, which is a change of state from solid to liquid. That answer seems correct. However, let's check all the options to make sure that we do not miss out on any of the other options. Freezing is not a change of state from liquid to gas, but a change of state from liquid to solid. Next, for option 3, evaporation. Water gains heat and evaporates to form water vapor. Hence, it should be a change of state from liquid to gas. Lastly, for the fourth option, we have condensation. Condensation is when water vapor condenses to form water droplets. Hence, it should be from a gaseous state to liquid state. After checking through all the options, which option is correct? That would be option 1. Next, let's look at question 2. The table below shows the freezing and boiling points of substances A and B, at which temperature is substance A a gas and substance B a liquid. Let's see. We should stop and highlight the keywords such as freezing and boiling points, temperature, substance A a gas, and substance B a liquid. Having read the information, I also need to take note of the information given in the table. This topic is related to the freezing and boiling points. I shall draw a number line to help myself with this question. So, firstly, for substance A, I'm going to draw a line with an arrow. Next, I'm going to mark 2 strokes and label them as freezing point, which is 10 degrees Celsius for A, and boiling point, which is 50 degrees Celsius for substance A. Below freezing point, substance A is a solid. And in between the freezing point and boiling point, it is a liquid. Above the temperature of boiling point, substance A would have turned into a gas. Next, if I want substance A to be a gas, it has to be above 50 degrees Celsius. Now let's try again for option B. For option B, I can do the similar choice, which is draw a number line and then to write down the freezing points and boiling points. Below freezing point, it is a solid, and in between, it is a liquid. Above the boiling point, it is in a gaseous state. Now, if I want substance B to remain as a liquid, it should be below 120 degrees Celsius. However, it should also be above 50 degrees Celsius in order for substance A to be a gas. Hence, the most likely answer will be option 3. Let's look at another way to do this question. Similarly, I'm going to stop and highlight the keywords. Next, I think about the 3 states of matter that are involved, which is solid, liquid, and gas. So, below freezing point, the substance will remain as a solid. So, let me write the capital S at this part of the table. Next, between freezing and boiling point, the substance A will remain as a liquid. So let me write the letter L in between these 2 temperatures. Next, above boiling point of a substance, it will be in gaseous state. So let me put a capital G over here. Let me do the same for substance B. I'll fill in the solid state, liquid, and gas. So, in order for A to be a gas and B to be a liquid, the temperature must be above 50 degrees Celsius but below 120 degrees Celsius. And hence, there you have it. Your answer is still option 3. The third question we are going to go through is an experimental type question. So we have to first find what is the aim of the experiment. Paul carried out an experiment to find out how long it would take 50 cubic centimeters of water to evaporate completely in different containers made of the same materials. He poured 50 cubic centimeters of water into each of the 4 containers A, B, C, and D, and left them in a room as shown in the diagram below. He recorded his findings in the table below. What would be the most likely time taken for the water in container D to evaporate completely? Let's practice our stop, think, and go. So let's stop and highlight some of the keywords and find out the aim of this question. So to find out how long it would take this amount of water to evaporate completely in different containers, and time taken for water in container D to evaporate completely. So this is the aim of the experiment. Now, what is the changed variable? The changed variable, is it different containers? What happens to the water when they are placed in different containers? The changed variable is actually the exposed surface area. of the water. Next, what is the measured variable? The measured variable is the time taken for the water to evaporate completely. Now, let's think of the concept. If the factor is an exposed surface area of the water, what would that affect? It would actually affect the rate of evaporation of water. In that case, what happens when there is greater exposed surface area? When there is greater exposed surface area, the rate of evaporation will be higher, and hence, less time will be taken for the water to evaporate. In this case, container D has water that has greater exposed surface area than container A. So, it should take less time for water to evaporate than A. However, D has greater exposed surface area than the water in C. So it will have a lower rate of evaporation and will take more time for the water to evaporate completely compared to container C. So, what do you think will be the most likely time taken for the water in container D to evaporate completely? It should take less time than container A, but more time than container C. Hence, the answer should be between 7 to 11 hours. And the answer is option 3. Now that we have done these 3 questions, try out stop, think and go on your other MCQ questions as well.
So for steps, we want to build concepts, we want to use stop, think, go, and thirdly, try the question, and lastly, check your answers. We will try out again. So thank you. If you have any questions, please drop them in the comment box below, and you can see how we can best help you. If you find it helpful, you may drop a comment as well and let us know. Thank you.